Okay, so here we have an example of binomial theorem. Let's say I have x squared plus 2 over x to the power of 8. And I have to find the coefficients of the following. So for the first one, I have to find the coefficients of x to the power of 7. Okay, now from binomial theorem, we know that, like recall, a to the power of n, a plus b to the power of n equals to cn choose 0, an b 0, plus cn choose 1, a n minus 1, b 1, plus dot dot dot, plus cn choose k, a n minus k, b k, plus dot dot dot, all the way to cn choose n, a 0, b n. Okay, now I would advise you to pause the video first and try out yourself. So, okay, I hope you tried already, and now let's get to it. So, for the first question, well, let's look at what a is and what b is. From the question, our a is x squared, our b is 2 over x, okay, and the coefficients of the following. So let's say I have a random term, cn choose k, a n minus k, and b to the power of k. If we plug in a equals x squared and b equals 2 over x, then it will be cn choose k times x squared 2d n minus k times times 2 over x to the power of k. And now, what's our n? So it's to the power of 8, meaning that our n equals 8. So let's write it. So 8 choose k. Okay, so now we have this expression, and we want x to the power of 7. So we can rewrite the whole thing as c8 choose k, x to the power of 2n minus 2k. Yeah, because there's a parenthesis here, and then the exponents, they multiply, times 2 to the power of k times x to the negative k. So to recall, 1 over x equals to x to the negative 1 power. Yeah, so here I just separated 2 and 1 over x into two different things. Yeah, and now, since we're looking at the term x to the 7th power, so we don't look at c8 choose k and 2 to the power of k first, because we don't really need that yet. So let's look at these two terms, right? Oh, n equals 8, sorry, so this will be 16. So x to the power of 16 minus 2k times x to the negative k will equal to x to the power of 7. And now it's just really easy, because the product of this will be x to the power of 16 minus 3k, and which equals to x to the power of 7. And if we equate the powers, then meaning that 9 will be 3k, because 16 minus 3k equals 7, and if we subtract 7 from 16 and put a 3k over, it will be 9 equals 3k. So as a result, k equals 3. Yeah, then we can know what our coefficient is, or what our coefficient is, because the coefficients are the multiplication, like other products of these two constants. So if we plug into k equals 3 inside, then we'll get this. So the coefficient, let's say COE, coefficient will be c8 choose 3 times 2 to the power of 3, because k equals 3, which will equal to 8 times 7 times 6 over 3 times 2 times 8, because 2 to the power of 3 is 8. And well, 3 to 1, where 3 to 1 equals 6, so these cancel out. So it will be 8 times 8 times 7 times 8, 56 times 8, which will be 464. Wait, 8. Wait, no, I'm stupid. So it's 40. Okay, never mind. my bad. 448. I got confused there for a bit. So the answer, the coefficient of the term x to the power of k will be 448. Okay? And now let's look at our second question. Again, it's the same thing. We look at a random term. Let me erase this whole bit. Random term, like this, like to the k. And then we equate this equals to x to the power of 5. So if we separate them, it'll be k times 2 to the power of k times x to the 16 minus 3k. Yeah, and then so this thing will be equal to x to the power of 5 because we want to look at the coefficients of to the power of 5. So 16 minus 3k equals 5, meaning that k equal to 11 over 3. Now you might think, wait, 11 over 3, it has to be a constant. You cannot, from 3 things, choose 1/2 of it because it doesn't make sense. You cannot cut a thing in half in this case. Like, let's say I have ABC. I want to choose half an alphabet out. You cannot separate B into 2, separate C into 2, or separate A into 2. You cannot do that. So, meaning that there's no such term in this expansion. There's no x to the power of 5. So then we write doesn't exist. Doesn't exist. Or you can just write 0, because if you multiply 0 by this, then it doesn't have any term. You can write either thing, but you have to put an explanation because k has to be a natural number. Yeah. Well, not natural number, but yeah, natural number and 0. Well, okay. And now the third question, 1 over x to the power of 5. Now, same thing. We equate, well, let's rewrite x to the 1 over x to the power of 5 equals to x to the power of negative 5. So if we equate 16 minus 3k equals negative 5, then we'll get 21 equals 3k, k equals 7. And if we plug in k equals 7, then from the formula here, then we'll get C8 choose 7 times 2 to the power of 7, which is, well, 8 times 2 to the power of 6 is 64, so times 2, 128, which will be, well, let's just multiply. And then, okay, which is our answer. So the coefficients of 1 over x to the power of 5 equals to 1024. So with regards to these questions, you simply just have to identify the term A, term B, and utilize this formula, and then equate it to the term that you want to do. And that's basically it. And a notable thing is that the k here and the n here, it has to be a natural number or 0 in order for the binomial theorem to work. Okay, that's basically it. I hope you understand this question and know how binomial theorems work, and in the future videos regarding permutation combination, I'll be going over all of the different kinds of, not all of them, but most of the different kinds of questions there are with regards to permutation and combination. And I hope you understood this question, and if not, you can practice it on your own and try to find the reasoning behind it yourself. And if you don't know why that is, or if you're stuck on a specific point, come back to this video and rewatch it. Then it helps you because you also think about the question as well. Okay, now see you all in the next video, I guess. Bye bye.